Hello, my name is Daniel Hernandez, and this is Lab Week 14, Part 1. Problem states reverse an array. Use a loop when indirect or indexed addressing to reverse the elements of an integer array in place. Do not copy the elements to any other array. Use the size of, type, and length of operators to make the program as flexible as possible if the array size should be changed in the future. So we begin by declaring our array and initializing it. It's my array byte 10, 20, 30, 40, 50, 60, 70, 80, and 90. We then declare a variable for our size, array size. We begin to write our code, so move edx into offset my array, which means we print our array. We call write string, move ECX into array size, and we move ECX to the loop counter. We move ESI into 0. ESI is basically the byte counter. We proceed to our first loop. So we move ZX, EX into my array ESI, which means we move the byte of the array into EX and push. So we push EX, increment ESI, we loop and pop the name and store it into the whole location. We move ECX into array size, we set up the loop counter, move ESI into 0, and we reset the byte counter. We move on into our second loop, so we pop EX, pop the numbers out of the stack. We move my array into ESI A low, which means we move the value into A low into array byte counter. We increment ESI and loop. We finally move EDX into offset my array, which prints all the new values in reverse. While we run it, we see that we print out our arrays 10, 20, 30, 40, 50, 60, 70, 80, and 90. And in reverse 10, 20, 30, 40, 50, 60, 70, 80, and 90.